Thank you for coming here. My topic is progress of WrapDrive. This is a common accelerator framework for user space. I'm Zaibo from Huawei. Today my contents included 5 parts. First, we want to look back at San Francisco 2018. Then we want to talk about the progress, and then the example, and current challenges. The last is our play on WrapDrive. Okay, let's come to look back on WrapDrive. This is from Kenneth Lee from HiSilicon. What is WrapDrive? Yes, I have said it's an accelerator framework for user space. Leverage hardware accelerator with native performance. On the left side is the architecture of WrapDrive. Secondly, it's based on WRFile and WRFile MDV, allowing direct access of hardware with improved security and efficiency. Hardware accelerator is accessed via a queue. This queue is the minimum working unit for user, and the queue's DMA priority is also controlled by the user. While WrapDrive, we try to get the native performance of accelerator, so the main target is performance. We also want to break the limit of one device server only one process with queue. Queue should be managed with more security. Status back then. And last year, shell virtual memory is also currently we call it SVA. Was in the phase of RFC, and substring ID was not supported by SMU driver at that time. As a result, WrapDrive supported only one process. This is the contents of WrapDrive's progress, the 3 parts. Firstly, it supports SVA, and then DMA mapping one device from multiple processes. At last, we try to keep compatibility, such as we keep the native driver in the kernel, and also keep the normal logic of MDV. Okay, let's talk about how we support SVA. We just extend SVA's patch set from gene flipper blocker of ARM. However, current version cannot support. I'm not sure can support or not support IO page fault. Because in theory, WrapDrive can support SVA, but right now no hardware accelerator is available to test. And at present, we use mlock to trigger page fault before DMA access, and also to prevent the page from being swapped. We do some tests on a HKG18 D06 board with Zaibo accelerator. This is an example, and I will show you in the next. Last, one WrapDrive device we call W device serves multiple processes, including kernel. This is because VFL can disband from Gene also, bind the MDUV queue to serve one process and show his page table. So accelerator supports pass ID with multiple queues can support multiple processes. Moreover, kernel default IO page tables pass ID is 0, which is existing as before. Okay, let's talk about the DMA mapping in multiple processes. We add VFL API for private VFL DMA map, similar to SVA VFL band and unband from Gene. This color maybe is not clear in this screen. The VFL IOMU attach and detach is add. VFL IOMU attach creates a path ID linked IOVA address space for the VFL container. Also, this IOVA address is retrieved while using a DMA map operation later. IOMU map and unmapped version with path ID is also added to the IOMU operations. Actually, this IOMM is denoting address space, and it includes a path ID. I think these two pairs of map and unmap may be merged in the future, because currently I do like this because I don't put any bad effects to the existing map and unmap of IOMU operations. More, to support multiple process DMA mapping, we extend the standard interface. A point to the parent device IOMU group is added to the VFL group. And second, a WDUV enabling method is added in the VFL IOMU type 1 attached group. You know, this logic is firstly, if this device is M device, then go to the if branch, and then if the MDUV is WDUV, then we go the WrapDrive branch. And low-mode mediated device handling is untouched, and also this mediated device is for vGPU. This is the relationship with VFL and MDUV. Cannot see clearly. I think this slide has some problem. Maybe as I put this in the wall. WrapDrive is moved into VFL as a part of VFL. We call it VFL WDUV at present. And a hardware queue can be a MDUV if the DUV is a WDUV. For MDUV from WDUV, VFL operations are finally applied on MDUV's parent device. This is the important point, because you use this logic, we don't need to unbind the native driver and just create the M device for user space. And one device support multiple processes without unbinding its native driver. And this finger, I just want to show the relationship of IOMU and devices with VFL and the user space process. Maybe this is not precise, I think, but I just show the idea. And two devices, each device has its IOMU domain, and in each domain we have several page tables, and as the path ID equals 0, the IO page table is for kernel, and as the path ID is larger than 0, the page table is for user space. These two devices, one device is used as a SVA scenario, and the other device is used for multiple DMA mapping scenario. This is an example to verify the scenarios as I talked before. They leave acceleration on a HKG18 D06 board using a zip accelerator. In the left is an overview of this sample. At first, synchronous and asynchronous mode APIs of WrapDrive are compared. Secondly, multiple DMA map and SVA without IO page fault scenarios compared. 3. Each scenario is run by 1 or 3 processes. 4. A range of different packet lengths are also shown. By the way, you can get the source code from this branch. It's based on 4.50. This slide just shows a raw throughput on HKG18 D06 board, and I put these two figures here just to show our WrapDrive can support SVA and multiple process DMA map, and it can running well. And performance is just okay, I think. Okay, let me explain the different scenarios. In the left finger, synchronous mode is showed. In the right finger, asynchronous mode is shown. And in each finger, 4 scenarios is tested. The first blue one is SVA without IO page fault and running one task. The orange one is SVA low IO page fault, but I running 3 tasks. The value is in average. The gray color is multiple mappings running one task. The yellow one is a multiple map with 3 tasks running, and the throughput is in average. And the right finger is the same as the left finger, but just in asynchronous mode. You know, as the packet is becoming longer, the bottleneck is a hardware limit, I think, because you know the throughput is the throughput of one task is 3 times as the average value of 3 tasks. Okay, let's talk about the current challenges. I think there are 3 aspects. You know, queue is not isolated as much as a task in the OS, so WrapDrive still exists. Security risk since several users work on one device, because the queue is not VF, it's just a queue. Secondly, WrapDrive queue management on VFL MDV is still, I think, a little awkward. For example, creating MDV for WrapDrive need root permission. I think this is also talked about in, from San Francisco 2017 from Kenneth Lee. And getting or putting a WrapDrive queue involves a series of SysMFS operations. More, MDV held by a process cannot be released automatically if the process exists with exception. And third, coexist with Linux kernel, crypto, and AFLG. I think this topic is sensitive and also controversial. Ecosystem is ready because device support Pass ID, PRI, ATS, and ATC. And the corresponding software such as VFIO and SVA is also in place. User space should be able to leverage accelerator directly with high performance law. That device can DMA from user space in a fast and secure way, since our ecosystem is ready. And last, I want to talk about the plan of WrapDrive. First, SVA with IO page fault will be supported. Secondly, we want to extend the other type of devices, like network card. I think this can benefit user space that play applications like ODP and DPK. At last, we want to optimize the VFL MDV framework to better support the requirements of WrapDrive. Okay, thank you.
Please use the mic. Please use the mic.
Hello? Yeah, okay. We're trying to do the same on Ethernet, okay?
Yeah.
So we did the same on Ethernet. We have results. But the problem is that when you create a mediated device, you get a new group, right? So every time you create a new mediated device, the kernel creates a new group. Yeah, when you do the IOPT and you create a mediated device, you get a new group. That's what the mediated framework does. So this group is dummy because it's not backed up by a real device. You have the same hardware and you have two groups for the same hardware, which is invalid. You have two groups for the same hardware, which is the hardware is going to issue the same requester ID. So unless you're talking about process space ID, we had an issue of changing the VFIOM dev API so that both the mediated device and the parent device end up on the same group.
When you talking about group, you mean the VFIO group?
Yes.
Or?
Yes, it's the same. VFIO group, IOMMU group, it's the same. It's an one-to-one meaning.
Okay, okay.
So when you created let's talk with numbers, it might be easier. So when you have an Ethernet interface and you start up the kernel, you get to group 25, the actual hardware network device. So when you create a new mediated device, the kernel is going to create a new group, which is going to call 26.
Yeah.
Right? So this is wrong because it's the same device and it's going to issue the same requester ID. So essentially to do this correct, you need the mediated device and the parent device to reside on the same group.
Yeah, I understand your meaning.
Because I've read the code, okay? I've read your code. So instead of doing what you do on the IMMU and figure out that it's a WrapDrive device and configure the parent operations like you do, you can just reassign the mediated device to the parents group and you're done. You don't need to do anything else.
I don't know why we need the MDV and the parent device in the same group.
Because it's a hardware, so it's gonna, unless it's a process space ID, which you're gonna issue a process space ID different per process, and it's okay.
Can I understand like this? The parent device is working in the kernel.
Correct.
But the MDV is working for user space,
Yep.
so they are in different groups.
No, you're on the same bus. You can't be on different groups. The device is gonna issue the same requester ID.
But MDV is the virtualized bus. It's not a real bus.
Yeah, but
VFIO group is a security concept. So
it doesn't matter.
If they are restrained in that domain, then you have to keep it in that domain. But I think we can change that.
Yeah. It's a virtualized device, I understand that, but when the actual device, the actual hardware is going to issue the DMA request, it's going to create the requester ID of the parent. It's not going to create a new requester ID. It cannot do that.
Maybe we can talk about after this is
Yeah,
going.
Sure.
Yeah, that's a good idea.
Yeah.
We should
Thank you.
Just a quick question. In your plans, are you planning for some automatic testing or performance regressions as you're concerned by performances?
You mean automatic testing and what?
And performance regression testing?
Performance testing, huh?
Yeah, both.
Yeah, automatic test maybe, I think, still have no play, but performance is our concentration. It's our target also.
Yeah, if you're concerned by performances, do you track performances automatically, or are you planning to do that later on?
Not sure.
But I don't get the question. Why you refer to this?
I'm just wondering if you're planning to create automatic testing for your your project.
But why? Why is it matter? Why? Why is it matter? you get my point? Yes, we do the testing, but that's all internal testing. So if you think that we need to do it public and you have some concern on that, you know how to do it. But I don't know why you care about it.
Because I'm caring a lot about testing. That's why I'm asking.
Okay, I think that the basic plan will be when we start publish it, we will try to cooperate with Linaro, and at that time the D06 board will be available in Linaro. Then maybe we will put into Linaro for the remaining testing.
Perfect.
Yeah. Any other question?
Okay, it's also time. Okay, thank you. Have a good day.